I already know the business. Oh, I don't have it on this computer. But you can like CD into files and basically do the same again. Back in some. I can actually pull them.
Okay, so we can get started. I do have an update to you guys on 310. So there's enough of you guys that 310 will be offered in spring. And I will be teaching. Have a new task to do. Make the course materials for 310.
Yes. What about the other upper divisions?
Uh,
Are they available next year?
That's another question for Ollie. There's only, I think, one other upper division that is CE.
I mean, look, he sent me, Jeffrey sent me an email from him.
Okay. Okay. All right. So today we're going to be focusing on projects that involve computer engineering at San Marcos. And the first thing that is, of course, computer engineering at San Marcos are your courses, right? So here I've listed all of the courses from the requirements on the degree planner for CE. So the few here are CS offered courses, right? So you need to, and I'm focusing more on the upper division courses because I think you guys are like all of you guys are trying to transfer to CE, so you've taken most of your lower division stuff, right? So for upper division, we need you guys to take CS 311. So how many of you guys have already taken 311? Okay, makes sense. All right, so data structures and algorithms. So this is going to be fulfilling that you need to know how algorithms work and data structures, right? When we talked about what is computer engineering, it's the cross between. Yes, electrical engineering and computer science. So this is your computer science background. The other CS thing that is required in terms of upper division is operating systems, right? So that's going to be like the scheduling, the sharing of resources, all of these things, right? So when you are building a system and it's going to be running some operating system, as a computer engineer, you should know the ins and outs of that operating system, or you might be writing that operating system, right? And then 331. So this is a course that I teach. You are in my course. You took it with me during the summer. You took it with me spring.
Yeah.
Right? I don't recognize anyone else. So if you take this course, you can take it with me or Mesa. So we are the two that teach this course. And I think later on it might only be Mesa because I'll be teaching more CE courses. So this is Introduction to Computer Architecture. So this is specifically how to design a general purpose CPU. But as I mentioned in our previous lectures, general purpose CPU is not the only microarchitecture that you can design, right? But this is a good class to kind of see a simple example and the most widely manufactured example of computer architecture. And then 303. So this is electrical engineering, signals and systems. So this is your digital signal processing course, part of electrical engineering that we talked about. So you would learn like Fourier transforms, things like that. And then 330, electronic circuits. So this is both linear and nonlinear circuits. So resistors, capacitors, and then transistors, MOSFETs. So you would learn a lot about how to evaluate a simple electronic circuit, what different things are used for, how an op amp works. You will learn more detailed electronic circuits here. And then, so CE and EE 491, this is a year-long capstone project. So you, as computer engineers, should try and get in a project that is more focused towards computer engineering. So an example of this was last year, I offered a project that was related to my research on FPGA design. So did we talk about FPGAs? I don't think we talked too much about FPGAs, right? Okay, so FPGAs, I'll talk again about them in the next slide because of 301, are programmable hardware. So you write what's called hardware design language, which describes the digital logic circuits. And that is taken in by the program and programmed onto the FPGA. The FPGA is field programmable gate array, and it basically turns the gates on the FPGA into that digital logic circuit. So that is one example of a project that I offered last year. I'm not doing this year, but I believe Mark Oberman, he's the E301 lab lecturer. He is offering a similar project with FPGAs or also microcontrollers. So there should be some computer engineering projects offered for this, whether it's from industry or like a project from here. Okay, and then other courses. So 301, digital logic design. So how many of you took 231? So everyone that took 331, all right, so 231, right? So you were introduced to digital logic and Boolean algebra, right? So this is like the next step. How can we design circuits in digital logic design to do more complex things, more complex algorithms? And how can we efficiently design them? And you'll learn how to use an FPGA.
Question about when you were talking about FPGA, is that the same as VHDL? Or
So VHDL is a hardware design language. So there are other hardware design languages, just like there are other programming languages, but they all just get translated to ultimately the schematic design that gets burned onto the FPGA. So another HDL that I personally prefer is System Verilog. And then there's also Verilog HDL. And I'm not aware of too many others. There are some others, like there's some open source ones too, but I haven't worked with them at all. Industry, for the most part, defense industry uses VHD because defense industry likes very old things, right? But Qualcomm is using System Verilog for most things. Apple is using System Verilog. Well, Google is using System Verilog. But like for Qualcomm, they also do some contracts with like communication. And for those things, they're using VHDL. But I don't know of any other things used in industry. But in 301, you learn VHD. And that's largely because of the industry advisory board. And the industry in San Diego is largely defense contractors, right? So they want you to learn VHDL. Most of our students stay in San Diego. They're working in defense contractor companies. That's General Atomics, Northrop, right? Viasat, these companies, they all want you to know VHDL. All right. So 310. It's going to be the continuation of this class. And it is a 3-unit class rather than a 1-unit class. So we can get into more details, more complex projects. And you'll also have the background from this class. Because this class is one of the requirements for 310. I think the other requirements is 231. And then 402. So 402 is also kind of a extension to this class as well, because they are introducing you to microcontroller systems and computer interfacing. So this is going to teach you more about the other kind of microcontrollers. You're going to do Arduino. You might do Raspberry Pi too, as well as the computer interfacing being the different protocols. Yeah.
Sorry, did you say that 310 units or what?
It's 3 units.
I think the page of computer engineering might be on them.
It says 1 unit.
Yeah, it does.
Maybe what I have is wrong. But if it's 1 unit, then I will check Curriculog, which is like our course proposal system. That has the for sure because it'll show me what was approved. But either way, we'll still have the course very similar to how we set up this one. So computer interfacing, this is going to be your different protocols, I2C, USB. Okay. So you'll learn about those. And then 335 is one of the electives that you can take. So it's going to, again, be very similar to the microcontroller systems course. And in the embedded systems course, Mesa also teaches this. I believe they go over Raspberry Pi. And it's a project-based class.
They also go over
What are those boards?
it's another. It's
Is it also ARM-based?
it's option.
And then 411 is required. So this is your system on chip design. And again, it's similar to this course. But the VLSI course will be more in depth on the transistor level, whereas the system on chip design is going to be closer to the hardware design level. So the hardware design language level. So the VLSI course will teach you more about transistor sizing and the importance of buffers, how many different stages should your circuits have, because counterintuitively, sometimes adding a buffer and making your stages longer is faster. So you'll learn more about that in VLSI design. And that is also elective. And I believe from the CE degree planner, you only have room for 1 elective. So you would basically be choosing between any of the CSE or CE courses, but right now, this is the only other one. But I'm kind of recommending this for this. Okay, so any questions? We're all good with these courses, why they're there, what you'll learn there. And maybe you've already taken some of these. Okay, so one other source of computer engineering is Robotics Club. So Robotics Club, I'm the faculty advisor for Robotics Club. And the reason that we have Robotics Club for the most part is there's no robotics course, right? There's no course that's dedicated to teach you guys about robotics. I would say yet. We'll see how we can, if we can grow Robotics Club, we can get enough interest, then we can create a course specifically for robotics. But we would need enough interest and enrollment to do that, right? But for now, if you want to learn about robotics, you still have Robotics Club. And just for your information, Robotics Club, they meet Saturdays from 10 a.m. to 1 p.m. And we meet in VEP, the Hunter Design Laboratory right here. So this is at the. So the main goal that I have with these students right now is to teach them ROS. So ROS is Robotics Operating System. So again, like we talked about before, this is system level design, right? And the very first thing that they learn is how can I integrate sensors and actuators as ROS nodes? And the reason that we like ROS, and also, again, industry likes ROS. So NASA uses ROS, Boston Dynamics uses ROS. Those assembly arms, like at a car assembly line, those are running ROS. Anything else that you can think of that's robotics? Oh, well, like I had mentioned, NASA uses ROS. The Mars rover, all of them, they run ROS. So ROS is very important to learn, so that you can work in these different industries. And it's basically the standard. And I don't know of any other operating system other than if they're making it themselves. And the other thing that's nice about ROS is it's open source. And the reason that we like ROS is it's one central system for communication. And we also have the flexibility in that all of our different nodes can support almost any programming language. So you can program one ROS node in C++, if that's what you're proficient in, and say your other team is working on like navigation or something like that, they're more proficient in Python, then they can use Python. And you can also develop multiple different programs for the same node with different programming languages, and you can easily just swap it out. So it's modular. So the way it works is you kind of have this central system. So let's call it ROS, right? And this itself would be a ROS node. And for the most part, it would be a listener. And there are two types of ROS nodes. There are listeners and there are publishers. So listeners are going to receive messages from publishers and then interact with the environment based on the information from the publishers. So we talked about sensors and actuators. Which type of node do you think a sensor would be?
Listener.
Sensor.
Would you?
a publisher, right? Because it's sensing from the outside and then it's publishing to Ross what that information is. And Ross is going to be also, is going to be the listener, right? And then actuators. So yeah, they would also be listeners because Ross is going to then publish, like, you need to turn your motor to 30 degrees, right? And then they could also be publishers sometimes because they can be reporting their angle or something like that. Okay. So that is kind of just an overview of Robotics Club, the things that they're learning. And in terms of the projects that they're working on, Robotics Club just started again last year. And I created a tutorial for them to kind of just introduce them to Ross, introduce them to the nodes, listeners, how to set up a system. And that tutorial series just makes a little robot car. And you can control it with a controller. And a group of them made it through that. And now that group that made it through is they haven't decided what they want to work on next. But for now, they're just using the robot car that they have and adding more sensors and actuators in order to do other things. Like one thing that they think that they will want to add is navigation. So for navigation, they're going to add that ultrasonic sensor for the distance. And they want to add a camera, but that is a little bit ambitious to work on at first. So I told them to just start with the ultrasonic sensor. Yeah. They're using Raspberry Pi.
Wouldn't be that ambitious. Getting the AI with it would be ambitious because there's.
Well, you can always just send it to cloud services. That's all. And you can also do very simple things like OpenCV. Yeah. So OpenCV, HAR filters. Like if you're just trying to follow a line, the Raspberry Pi can do that.
There's like an open source software that's already on FFmpeg. Like a camera and goes into things.
Okay. It could be something that they look into, but I told them to hold off for now. Just start with the ultrasonic sensor, get it to stop if there's something in front of it, and we'll move from there, right? So we have new students coming in. Basically, we have 5 of these robot cars. So one is built, and the new students coming in can work on that tutorial series. And the older students from last year can help them with that. And then hopefully we can keep evolving as we go. So again, if you are interested in learning robotics, Saturday, 3-hour block, VEP. And there's no requirements, you can just show up. But I don't think there's a meeting this Saturday. So if you are interested in showing up, do just confirm with me or anyone involved with the club that there's a meeting. And the other thing that I do is when there is a meeting, I send out to CS majors that there is a meeting. Okay. So any questions on this? All right. So, well, we kind of already went over this, right? The robot car example. All right, so the other place, computer engineering. So I do research in kind of a wide variety of different places, but my main research thread is hyperdimensional computing. So hyperdimensional computing is a lightweight machine learning algorithm. So it's more geared towards running locally on something like, say, a Raspberry Pi. But what makes it, and my projects, more geared towards computer engineering is I'm not trying to run on a Raspberry Pi because Raspberry Pi is, again, general purpose computes, right? So general purpose computes equals inefficient, right? You're doing a lot of overhead in order to do general purpose compute. So it's computer engineering focused because we are doing hardware design. So we are working with FPGAs. We have a tape out for an ASIC chip. And the other thread is we are looking into non-traditional computing methods in order to implement hypervector computing. So we all know von Neumann architecture. Don't remember von Neumann architecture? Okay, so von Neumann architecture is the basis of general purpose. So you have your processor, and then you have this area where you store memory. So your program and also your data. And in order to do any computes, you move the data from the memory to the processor, process, write it back to memory. That's von Neumann architecture. So we remember it now? Okay. So if you have a lot of data, then moving the data can be a very large portion of your energy. And especially if your compute is very simple. And hypervector computing, the compute is very simple. All of its operations are bitwise. So it's all bitwise AND, bitwise OR, bitwise XOR, things like that. So it's very simple to implement. So it's a better fit for this new emerging technology, processing and memory. So rather than moving the data from memory into the compute area, we're just going to leave the memory and the data where it is and computes right on the memory. So we have classic architectures, ASIC design, but we're also looking into emerging computing architectures with things like processing and memory. And there are lots of different kinds of processing and memory. There's compute near memory, there's actual computing with memory, and then there's new emerging technology like analog ReRAM, there's digital ReRAM, and there's processing in flash. So there's lots of new types of up and coming processing and memory architectures. And this is also a field that is being used for neural network architectures. There's also a company in Texas, I believe, that is actually manufacturing analog processing and memory for neural networks. And this is going to be an increasingly growing field because of the end of Moore's law, right? So we can't make general purpose processors much faster anymore. We're at the limits. So we need to make it faster by, like I mentioned, making accelerators. So accelerators can be based on the same transistor design ASICs that we talked about. It can be on FPGAs, or it can be new emerging hardware, like processing. Okay, and the other thing that I do is I worked on this. I don't really do this anymore, but we did bioinformatics acceleration. So we did acceleration for DNA sequencing. So the basically state of the art was, again, general purpose CPU compute. And even worse, the state of the art was single threaded. And we were working on DNA sequencing. So before we were involved in this project, the lab that we were working with, when they wanted to process a sample from the sequencer, it would be on the order of weeks in order to get the results from CPU. And after we've first we optimize on CPU, multi-threaded, multiple computers, pipelining. And just with that, they were going from weeks to a day. And then we were also working on, theoretically, if we map this to processing and memory, we're going from day to minutes. But this hardware does not exist. It's just theoretical. So the end goal was basically, and written in the paper, on the sequencer, you put this embedded system that has processing and memory capability for their DNA sequencing algorithm. And you get just the sequencer outputs, it processes, you get your data immediately. Right? So that would be an example of computer engineering, right? And then the other thing, this is not a project that I was involved in, but it is a project that I presented a few times. And it's from my PhD lab at UCSD. So one of the main problems we have here in San Diego are wildfires, right? And we want to know when a wildfire starts, right? But we can't just put 1 million sensors out in these remote areas. It would cost too much, correct? So one thing that you can do is have a moving sensor, right? So what do you think is a good moving sensor?
Satellites.
So satellites could work. What else? If you want more detailed information, because satellite is very far away, right? What's something that could be closer that could move? So automated drone, right? Then the question becomes, how many drones should you have? How long should a drone be in this one specific area? And especially for our application, right? Our application is we want to know if a fire has started. So it's not, if you sense this one area, you can be relatively confident for say like 30 minutes, an hour, that there's still no fire in the area. You don't need the drone to stay there. So the drone can go somewhere else. So going back to algorithms, we have different node points, right? And we need to visit all those node points, and we need to be relatively confident that there's no fire still there. So we need to have this pathing algorithm for the drone to follow. So that's something that they do. So those are some different computer engineering things at San Marcos. We have, so we went over courses, right? Went over robotics, and then these 4 different research areas. So now, you guys have been on campus for how long? On average, more than a year, yes? Anyone less than a year? Are you just now coming here? Okay. So try and find someone that has been here a little bit longer for this activity. And I want you to think about what are the other projects around campus that are involving computer engineering that you've seen. Could be clubs, it could be anything, right?
It's the poll everywhere. P.
Yeah, so answer the poll everywhere when you have a project and you are done discussing. The code is 533.
Oh, I know about that. Yeah. That's part of a commercial. It's something. Yeah. They bought more
It's a good both part, hard to go home.
But it's,
I think it's a hybrid.
it's not hybrid, it's more smart. I watch them, they have like a, that's like sensors on there.
She's still, she had some, she had her season, she's after 2 weeks.
Yeah, she's still out this week. She's back next week, right?
Yeah, but it's sort of because like, oh, it's just like, it's just like a few TAs, like,
What do you guys do? Like she comes in.
yeah, I don't do the lecture, but like, yeah, they just.
They just ask you a bunch of questions, because obviously she's fine.
He's like, oh, that was good. Come on.
What? You really talk to them.
This all the show.
No, thanks to the trash, I got working for no. Because they're very bad. Yeah, I'm ready to tell you. That's why they're so kind of.
I think they're just getting.
Why would they? Oh, wait, they start. Or start with MIPS, right?
Okay, the poll is activated. So when you are done discussing, yeah, finish. And the code is 533.
Have you been for about a year?
Yeah, around there.
Okay.
Yeah.
Because I've only been here for.
Oh,
Oh, wait, no, I didn't transfer, actually, I'm just pictures.
oh, okay.
Yeah.
Are you letting someone?
It's pretty interesting. There's a few things I don't really know, it's like.
Yeah.
It's close to everyone. Nobody goes to the
Clubs or.
Clubs? No. This is last year.
Oh, yeah.
Yeah.
Oh,
Came from his driveway.
and,
What?
Yeah, or maybe like a permit.
yeah, I mean, that's your real one.
Yeah.
Yeah.
And,
That's Jeffrey. It looks like you're trying to work something out.
Yeah.
Okay. Yeah.
There's securities and loans.
Did you hear about the community?
Yeah.
It's supposed to be.
How do you hear about it?
I mean,
Two.
well, I came here to teach science, but in the back of my mind, I would really hope program.
No, it's in his pocket.
Oh, yeah.
Oh, that's good.
That's like.
You didn't play for other Asian games or?
It's like
I did, but
Oh, yeah.
all the colors.
That would be- If cameras were being installed. Then,
Okay.
Yeah, that's fine, so that's basically.
Oh, yeah, you're not tired.
A somewhat small campus.
Yeah, there's like, they do like.
Like, that's
also-
Yeah.
Okay.
And,
I'm gonna go rob them.
I was thinking of maybe transferring to.
You're there all the time. That's the reason.
I was thinking.
More see.
Awesome. I recommend not.
Oh, really?
Yeah, I mean, it's like 15 weeks there.
Oh.
Yeah. You're like on a time.
So,
I mean, unless you can handle it.
Yeah.
But
Yeah. So people are.
yeah, I don't even know how the order system works.
Better to
So
look.
it's basically, you know, semester it's different. They have 3.
Yeah.
10 weeks each. So like they have to tweet us every 5 weeks of content.
So you beat that up and then my brother, what, they have like a large gap in between.
No, I don't think there's not much of a gap.
Dude, I wish I had someone like this bad.
Oh, I thought you said.
Maybe between like quarter and like with the border, but I don't know about.
Because I know our semester system here, there's like a month and a half gap between the semester. Like a half month gap between each quarter or something.
Like, so we have somewhere to 2 weeks. Cause they gotta get all this.
I just like that makes it right. He's supposed to.
Hey, man, you wanna, we used to do like someone edition. I went, like, I went, I didn't go there. Cause I wasn't on
Thinking
Saturday.
to like get people to invest in this.
Right, it's the beach too, that's right.
Because he has
Yeah.
4 friends that,
Well,
they already made
I
it,
heard
like,
about
already
the
more
course
things that they're doing now.
Yeah.
But he's trying to get more people to invest.
Because I was
Putting
thinking
it
about
down. Like, Kirby.
Well, if you wanna learn more, ask him about it, cause he's part of that. He graduated.
Board members from last year.
Yeah.
Your name, by the way?
Mason.
Would you?
What?
What?
Oh, okay, so this is
I
like-
would get mad if they have.
Alright, so there was a place where people started
Mason.
Yeah.
It might be.
Maybe I'll let it go fill out my. Thanks for the information. Maybe it's not.
You're the issue. You should have gone like the hello time, right?
No, dude, my shit to like stack and like post fix about.
Oh, you're still gonna see.
So do you have anything?
Let's say use one like an elevator, cause that's just there, so that when you walk in, you're in there, like, nobody's into it. And then if nobody's walking in through, you close it. That's it.
That's not.
You don't know anything like on go?
No, I don't.
So I'm kind of using this also to like
Yeah.
figure out if there's anything I don't know.
Okay.
Almost like a picture.
Okay.
There's a bit of sensors inside. Is it like it's supposed to be? There's no blue things that do this room. Something. So, yeah, it's not over there. Then turn like the lights on.
Oh.
And then, I guess like it's mom's, but in VP with the.
Yes.
Circle word.
Uh-huh.
Yeah. so but that has, the motorized fin. And like it can sense.
Okay.
That's it.
Yeah, if you say like trouble copying pasting, that would be so like, come on.
Oh, last year, but water bottle. It's like. No, you're not supposed to do. The water. The Mars. I don't want it to do the. Yeah. Oh, yeah. Yeah, for 2:31. Well, she said like it's 8:30, 9:30, but I have class.
Yeah, I'm doing something objective.
So like I.
I don't know.
Well, I just got it.
It's only Monday, Wednesday, Friday. Like I can't do that.
That's like, they do.
I asked her for like Tuesday, Thursday. I feel like we can bored. She doesn't say that because like.
I just heard that
She doesn't know.
Yeah. Oh, I was so confused. Like Trevor sent me stuff like, why is my name on here with 2 lines? I was like,
Oh, what?
Okay, so we have just about 5 minutes left. So do answer the poll everywhere and click complete to make sure that you get your attendance for today. And along those same lines, so I did post the attendance results for lecture 2 and 3 from last week. And after manually reviewing them, there are still some of you that are answering with not your student ID. I think one person is using email ID, and then 2 people are using their name and last name, which is the default. So do change those, check those to make sure that you'll get the credits automatically with the script. And if you are seeing a 0 and you were here, make a private post on Piazza to me or email, just something where I have a reference of I need to change this, and I'll reply back to you when I've changed it, and you can double check. And then the last thing I want to chat about is we had some examples. I walked around and talked to you guys. Okay. So one example, and I talked to you guys when I clarified what I wanted, but a lot of you guys came up with like pre-existing things, kind of like what we talked about before. So pre-existing things are like, some of you guys talked about elevators, water bottle filling stations. You guys talked about the rooms and the sensors and how this door is supposed to unlock at 7:30 a.m., but it didn't. And what else was there? So elevators, water bottle, oh, trash cans. You told me about trash cans, right? So those are a lot of pre-existing systems, which would fall in the same category of like the vending machine that we talked about. And then ongoing projects. So ongoing projects would be like the ones that I presented today. So like the robotics club is ongoing. My research is ongoing. So there might be other professors, like our department chair, Ali, but he is still active in research. His background is in systems. So he does computer engineering projects. I'm collaborating with him on a project along with Nadimi. So we are collaborating with each other. Another thing, you mentioned Tom. So Tom is another good example. So the example that you mentioned was the surfboard that's in VEP. So the surfboard is meant to enable Tom is partnered with Perry, which is like a school for autistic children. And one of the children, he just wants to surf, but he doesn't have the motor skills to surf. So that's what the surfboard is for. There was someone mentioned Cybersecurity Club. So Cybersecurity Club can also be an example of computer engineering because a lot of security issues happen at the hardware level. Like an example was Intel Spectre, that one, which had to do with accessing any area of memory. So there are lots of examples. You can look at the research from the faculty for more examples. Clubs are good places to look if you want more examples. But just to end with, we are going to start working on homework 1 in class on Friday. And the lecture slide is uploaded so you can see exactly what homework 1 is, but I can also describe it to you really quick. So what I want you to do is like find someone that is not me, that is working on an ongoing computer engineering project at San Marcos, and come up with 3 unique questions. Like should be kind of tailored to their project or their expertise, and kind of just a short interview and report back what they say. And we'll start working on that in class. So in class, you can find someone, develop your questions, and then like during the week, send them the questions, something like that. Okay? So any questions for me? Yeah.
On one with the professor, can I just ask that professor? Okay.
Anything else? Okay. So that is the end. There's no homework for you guys to do just yet. You can start thinking about it. But again, we will work on it in class because we are a 1-unit class, right? So,
I'm doing like a giant project right now with Madame. This is.
Yeah, I'm gonna do it today, but